All right, welcome back. So we are going to be finishing our differentials homework here and taking a look at what we have. And I'm going to go ahead and share my screen so we can get some work done. You guys can see what's happening. All right, so for this one, we are looking at the volume of aluminum can, the volume of aluminum needed for a beverage can that is approximately this tall. Okay, and can I get another one? No, I can't. All right. So let's have a look at it. Okay. So what we're going to note is that the volume is equal to pi r squared h. And since this is the chapter on differentials, we're going to go ahead and see what's going to happen here. So this is the dv part of it. Okay, so what we're going to do is we're going to say that this is going to be dv by dr times dr plus dv by dh times dh. Okay, this is one of these funky d's. Okay, so and let's see where this this gives us. I think this is going to be the like the thickness, like the if we're going to be looking at like a dv type of a thing, that it's like a tiny little part of the volume. So I think what we're going to be dealing with is something like this. Let's go ahead and do that. So I think we're going to be getting like this tiny piece here, this tiny piece here, this tiny piece here, okay, and this tiny piece here, okay, to go all the way around it. Okay, so I think this is what we're dealing with, is this thickness right here. Okay, let's go ahead and make this a little bit bigger because I have a feeling it's going to be positive. So you can think about like a little, like, yeah, the volume of the here's the volume of the soda, right, or the beverage, whatever. And then just a tiny little bit, right? This is the envelope, right, that goes around it, that is the can. So I think that's what we're going to be dealing with. It's way too big for DE. Okay, so you think like the brown stuff here is going to be a soda or Coke, and then like this little purple spot outside of it, that's going to be our tiny little bits more. Okay, so let's go ahead and do that. All right, so total derivative here. So let's see here. Let's put this up here. Okay, so dv is equal to, what is this derivative here with respect to r? It's going to be 2 pi rh, okay, times dr, okay, plus with respect to h, we're going to have pi r squared. The h is 1, so we're not going to worry about that. And then we have our dh. Okay, and let's take a look at what's going on here. So we've got a centimeters for the radius, we got a centimeters for the height, and we've got a centimeters for the dr part, you know, the radius squared. So I think we have 2 of them. Okay, so I think we're going to be okay there. And then this guy is a r squared, and then times a dh, so we've got a volume plus a volume, we're good. Okay, so what did we have? We had our r, our v, and then our d thickness. So this is dr, which is dh, I believe. All right. So what do we have? We have 0.11. Okay. So what was our values? Our radius was 3.5. And our height was 18. There we go, 18. All right, and then we're just going to go plug this stuff in. Okay, let's see what happens. So we have 2 pi, okay, and this is going to be 3.5, 2 pi r h, there's no squared here, it's just h, okay, times 18, okay, and then dr was 0.11. Okay, and then we have pi, and then we have 3.5 squared, and then we have dh, which was 0.11. Okay, I think because like the can wraps around itself, right? We've got a 0.11 here and a 0.11 there. So I think this is actually going to be 0.22, but we'll see in a moment. Okay. So let's see here. All right. So we have 2 times pi times 18 times 0.11 equals, and this was 12.44 plus, okay, this was pi times 3.5 squared. I'm going to try 0.11 first, okay, and trust we don't have to think here. 4.23, I believe, right? 4.23? 4.23, okay. So let's go ahead and add those up. So we have plus 12.44. We end up with 16.67. All right, and we'll go ahead and put that in here. Volume of aluminum needed, 16.67. Here we go. 67. Oh, this is my final check. If I don't get this right, that is incorrect. Let's redo that. Okay. So we have the same formula, right? It's still a cylinder. We're still trying to figure out the beverage if we can. Radius 1.5, height is 18, so it's going to look like one of those monster drinks. So let's see here. It's a tall, skinny drink, 1.5. Height is equal to, let's see what we have here, 18. And we're saying that dr is equal to dh, which is equal to 0.07. Okay, so let's try it with same idea here, right? This is 2 pi r h dr plus pi r squared dh. Okay, so this is 2 pi 1.5. H was 18 plus pi, oops, we need a 0.07 here, plus pi r squared, so this is 1.5 squared, and then we have a 0.07. Okay. So actually, if I could make this formula just a little bit easier, we have pi times r, and I have 2h plus r times dr. Actually, let's keep the dr in here, dh. Okay, so we have pi r 2h dr plus r dh. Because I think that this dh actually has to be 0.07 times 2 because we're wrapping the same thing around it twice. So 0.4 and 4. Okay. So here we go. We have pi 1.5, 2 times 18 times 0.07 plus, okay, plus 1.5 times 0.14. Okay, let's see about that. Okay, 3 divided by 2. Well, so let's just do the way they did it. 1.5 times pi times, now we have 2 times 18 times 0.07, okay, plus 1.5 times 0.14. Okay. I don't like this. 12.86. Okay, that was okay then. All right, so notice when we do this, right, we have centimeters times centimeters or centimeters times centimeters. So we have length times length times length. So that should be length cubed, which is a volume. So I'm pretty happy about the fact that we came up with a volume there. Okay. So this is a similar type of a thing. I feel a little bit better about this one because the bone is solid. Okay. So a piece of bone in the shape of a right cylinder is 4. I wish they would have started with this one. Piece of bone in the shape of a right circular cylinder is 4 centimeters long, radius of 2.3 centimeters. It is coated with a layer of preservative 0.05 centimeters thick. Estimate the volume of the preservative used. Okay, so again, volume equals pi r squared h. Okay, so we want our dV to be derivative of volume with respect to r times r plus derivative of volume with respect to h times dh. Okay, so what are we going to do with that? Well, actually, we're going to need 2 times h here, right? 2 times dh. So our dr equals dh was equal to 0.05. Okay, so a nickel. dh times 2 was 0.10, right? Because we have a same thing on the both of them. Okay. So we'll just use the same thing, the same setup as we did for the Coke can there. Okay. So we are going to have 2 pi r h dr plus, okay, we have pi r squared times dh. Okay, and again, we do have our volume thing going on here. So here we go. We have kind of pull out. Actually, you know what? We're going to do this 2 dr because that's equal to h, right? Because we're going to double it. So I've got a 2 and a pi common to both of these. So we can say 2 pi r. Okay, and what do we have left? We have an h plus an r. Because one of the r's is gone. So we have an h because 2 pi r is gone. 2 pi r is gone. We have 2 pi. And then we have a dr here. Okay, so we have 2 pi. What is my radius? My radius is 2.3, and my height is 4 plus 2.3, and it is layered with 0.05. Okay, you don't need to go through all of this arithmetic stuff. If you just want to type in the formula as seen as you've calculated it, you go right ahead and do that. Okay, that is, there's nothing wrong with that whatsoever. Okay, I'm just not as good with a calculator. Okay, times 4 plus 2.3. Okay. And then times 0.05. Okay, we got 4.55 centimeters cubed here. Okay. 3 decimal places. 4.552. All right. All right. Okay, we got the height of it. This is a different one. Okay, so we got the height of a triangle. Okay, measuring 28.8. The base of the triangle, 12.2. Measurement of the height can be off by as much as 0.9, and the base could be no more than, and the base by no more than 1.3. Okay, so estimate the maximum possible area in calculating the triangle's height. All right. So what we're going to do Okay, they just want the maximum error. They don't want the maximum possible height. Okay, so we're going to say the area is equal to 1/2 base times height, right? So we're going to take our dA, right, our total area. So we're going to say this is dA by dB, plus dA by dH, Does that make sense that we set it up this way and have our possible area weighted by our dB, our possible error weighted by dH? Okay, and we're going to add those together. Okay, so fortunately, these are both to the 1 power, right? There's not a big deal. So we take these derivatives, it's just going to be like 1. So we have 1/2 h times the error in our height plus 1/2 our base times the error in our height. So we have our error in base, error, excuse me, height. Okay, now when we go here, we're going to say this is 1/2. The height could be off by as much as, what's our height? At first I'm glad they didn't ask us to do this. So I was expecting to have to approximate the 28.8, right, with a 1.2 possible thing with that, doing some kind of a weird second derivative thing, second order total derivative. We never did those. Okay. So the height, we got that written down, and our dB base could be off by no more than 1.3 plus 1/2. Our base, what is our base? Our base is 12.2, and the height could be off as no more than 0.9. Okay. You say, how do you do that? Look, to be honest with you, we never did anything like that. Okay. So this actually looks like a good question to ask you, by the way. I like this. This is pretty straightforward. You don't have a weird thing talking about surface areas for the last one. I kind of like this as a problem. It's a very straightforward word problem. I think that's a good choice. Okay, so 1/2 times 12.2 times 0.9. Okay, 5.49 is equal to. Okay, so 5.49 plus 18.72 is 24.21 centimeters squared. Okay, so let me say this is 24.21. Oh, they didn't even ask us to put a decimal point on it because they already know. Oh, great. I like that kind of a question too, because it minimizes the kind of mistakes you could make. Like everybody's going to get the same answer. It's easy to grade. Okay. So if you're wondering, what is he possibly going to ask us? Partial as a word problem. If I pick a word problem for differentials, I am partial to this one. Okay, this is a very straightforward problem. You guys should have no trouble with this. And it gets to everything I would want to ask about. It's like, do you understand what's going on? Sure. Okay, let's go ahead and stop the video and we'll go through. As far as like a word problem type of a thing, what did we do? No, this one, I don't mind this one either. Not too bad. Let's see. I don't like this one as much as I like number one. Number one, I like a lot, right? Number two, not as much. Number three, I don't like the x e to the x, x e to the y. Like, that one's been a little bit harder, but this would be a reasonable amount. The logarithm one, I like more. Okay, so we'll stop and then we'll get to the next section.